Hello, everybody. Today we are talking about fine tuning, but we're going to deep dive a little bit in fine tuning from a different perspective. Today we have with us Brandon. So, Brandon, do you want to introduce a little bit yourself?
Yeah. Hey, I'm Brandon. I'm right now a senior research scientist here at Databricks. I lead a lot of the RLHF efforts here. So that covers basically a lot of this post-training ideas, how to fine-tune models, how to make models basically align more with what you want them to do. Yeah.
Amazing, thanks. And then let's start a little bit with what is the main challenge with fine tuning that you've seen as you are working on this?
Yeah, I think fine-tuning, especially for customers, is that they lack a lot of these, in a traditional fine-tuning sense, these prompt response pairs. Usually with fine-tuning, you need to have these very high quality input-output pairs that you fine-tune on. Unfortunately, though, these like don't really exist in the wild, right? This is very bespoke data. It's very hard to find. So this is just like one of the core challenges with this normal fine-tuning that we've encountered.
Like collecting questions, answers across multiple examples.
Exactly. Yeah. Or question answer pairs. If you're doing a question answering task, if you're doing a coding question saying, if someone asks you, hey, can you write this Python program to write the script to plot this data for me? Stuff like that's like very, very hard to find in just normal web scrapes or in the wild. So that's just a very, very core challenge that we've seen with a lot of customers.
Very interesting. And then before we go into how we on Databricks are trying to solve that, do you have any idea how the competition is trying to solve this like OpenAI?
Yeah, I think OpenAI has done a few things in this. One is they've done some model distillation work where they say, hey, we can take, GPT-4o, train on its input-output pairs. User provides some inputs, and then
Yep.
you take the GPT-4o outputs, and you can fine-tune a smaller model. So GPT-4o mini for them usually. The alternative to this distillation method is basically they have something called reinforcement fine tuning, where you basically say, hey, here's my set of prompts. I think in the example they gave, they were optimizing uh, some protein sequence basically over time. And they're saying, hey, can we have these language models run these very bespoke measurements in protein sequence modeling? If for this case you need like a pretty good ground truth verifier or some signal that says, hey, you're improving over time. And so basically what they do is they say, here's your set of prompts, you run this reinforcement fine tuning over a set of prompts, and over time you should see your model get better given this ground truth verifier on your given task.
Nice. And then if we come to what we are doing, we're doing something a little bit different. So we call it soft synthetic output fine tuning. So can we describe a little bit what is this mainly?
Yeah, so in a similar vein to kind of what OpenAI is doing, all we require customers to do is bring a set of prompts.
Mm,
And this basically says, hey, I want my task to do this. If it's in the RAD case, I want my model to be able to answer questions about my documents on my given RAD case. If it's in extraction information, it's like saying, hey, given this structured output, I want to get this unstructured output. I want to take output this structured kind of query basically. Or if it's in a chat case where it's saying answering generic questions around things, same story there basically. So again, the core thing here is all we ask the customer doing is bring a set of prompts, and over that set of prompts, we will try to optimize the model to produce more better outputs on their given domain.
very interesting. And then should we go through exactly the steps of the process?
Yeah, so explicitly how the steps of soft work. First, basically what we do is we again take your prompts. Then what we do is we overgenerate on the set of prompts. Basically, language models typically have this ability to generate a correct answer. The core insight here is that we just need to be able to filter for the right answer or have some
Mm.
verifier. Say, hey, this is right or this is partially correct, basically. And then from there, we can basically rank all these outputs and then use basically these underlying RLHF algorithms that say, hey, we can now optimize the model's responses over now this prompt now given response pair, basically. And so this is a bit of a combination in some sense of a lot of different ideas that exist in academic literature, but overall it provides this general sense of, hey, all you need to do is bring prompts and we can optimize the model's responses over the set of prompts, essentially.
Have you worked with some customers to see how this performs and how much effort actually requires?
Yeah, right now, Soft is in a research preview, and so we're doing a lot of research to understand and better characterize these methods. If you would want to work with Soft to basically say, hey, maybe OpenAI or Gemini or whatever model you're using isn't quite good enough, we can help you basically apply Soft to these llama models and help improve the model fidelity. So in an academic setting or like on the more canonical benchmarks that exist in open source, we've been able to definitely see improvements through soft, and we'd love to try it with you in the enterprise setting.
Nice. Should we see how it works? Go through the
Yeah,
demo?
yeah. So basically, from our perspective, soft consists of four perspectives. Currently, all these are in notebook/job form. But basically, all you would do is you would first just provide your prompts. And then basically this notebook here would basically say, okay, let's take for each prompt, we generate a lot of responses from a given model. And then basically what we do is we then want to score all these prompts with the reward model, basically. And what this means is that you can say, hey, your first response is good, second response is better, fifth response wasn't as good, and you can kind of have this stack rank ordering of all these prompts, all the responses basically per prompt.
Sorry
And
to
then what we,
interrupt. What is
yes.
the difference then between the model that's going to, so you generate a lot of outputs and then you're going to like rank them with a reward model. So what's the difference then between the reward model and the model that generated those outputs? Or are we using the same or are we using a more powerful model to do that?
Yeah, that's a really good question. So this is kind of an implementation detail that's under the hood. So in some cases, you could use a more powerful model under the hood. Just to say, hey, like this, like response A is better than B, B is worse than D, and stuff like that, basically, and give some basically ranking of these outputs. But explicitly, one other alternative to this is you can use a language model and then train it to basically be this what's called a reward model. And reward models are basically the core heart of RLHF. They basically have this ability to rank and order these prompt response pairs, and that's explicitly what they're trained to do. Their job is literally just rank this data. And so you basically could take like a Llama 7BB, have basically data to train it to be able to rank all these outputs in that fashion of like, hey, A is better than B, B is better than C, but then D is better than A. And you're trying to basically make this model just be able to rank outputs very effectively.
So then if a Databricks customer wants to go through this process with you, then the reward model is already pre-trained, right? They don't have to deal with this.
Yeah, exactly. So we
Okay.
spend a lot of time and effort basically training on reward models, making sure on given tasks they work effectively, evaluate them consistently, and we're always updating them from our side. But yeah,
And then on the
okay,
fine-tuning side,
yes.
on the LLM fine-tuning, so this is any LLM they want to use, right? Are there any specifications on the number of parameters or any would do?
Yeah, I think the canonical answer so far is any will do basically. And so it could be, Llama 3B, Llama 8B, Llama
Hmm.
70B. Those are usually the ones that we work most comfortably with.
Hmm.
And then again, right now Databricks is very Llama forward. So again, those are the core models that are supported with basically this method of fine-tuning, at least on Databricks side. Yeah.
Amazing.
And so yeah, continuing, these were great questions, obviously, from Laura and Maria. And then once we basically, from our side, we have this reward model that'll basically say, hey, across all these responses, we can rank all these responses and say which ones are good or bad, basically. And then from there, from this ranking, we can apply underlying methods of just normal just fine tuning, because now we have these prompt response pairs that don't really exist in the wild. Or alternatively, we can use more advanced methods, let's say DPO, or more RL like methods to optimize your LLM to do well in your task, basically. And then the last final step, once you fine tune your model, is again run on your given eval. For the research team, initially this was again as stated in this slide, basically um, Arena Hard. It's an open benchmark that basically tries to say, hey, how good are these models outputs against, let's say, the original GPT-4 outputs, and how often would you win? But again, for a customer, this could be your given eval, whatever you built. It could be from the managed agent eval service, where it says, hey, on these RAG use cases, how factually accurate are these answers? Was my model faithful to the context? Stuff like that. So again, this should apply to any generic eval, but again, this is a like a little bit of research idea and topic, but overall, we should still be able to increase your fidelity for these model outputs.
Okay. Have you done any research or created some baseline on the number of tokens we have to pass in the prompts? Like how big or small the prompts should be?
Yeah, so I think the per prompt the token size I think is agnostic, or at least that's my general
Mm,
intuition there. We haven't done any explicit saying, hey, like, prompt needs to at least be like 10 tokens, or it has to at
mm,
least be like 1,000 tokens. I think the bigger thing is the number of sample, no, the number of prompts a customer needs to provide, for example.
okay.
And so explicitly what this is from some preliminary benchmarking, I think around 5 to 10K is very safe. 1K we can definitely try it and we can help you augment it or work with you on that and see what happens basically. But I'd say at least 5 to 10K prompts is where we can start seeing some good signal soft. Yeah.
Mm.
So you need more than usual, but we can also help customers if they need more.
Exactly, yeah. Because I think so for soft, basically, or what this kind of method does is we're trying to really increase the model's ability to effectively output better responses overall. A lot of if in the fine-tuning setting, if we're doing only a few hundred samples, it's usually a lot of like style stuff that occurs. We're saying, hey, I want, the model to sound a little more like Old English writing. I want it to be a little more in a poem form, stuff like that, more than true understanding of the task at hand, basically. Yeah.
And then synthetically generating more prompts based on a good quality of prompts provided. Is this an option?
It's an option. It's an open research direction. It'd take a bit of
Okay.
work, I think, and a little more involvement with, say, an essay or something. But I think it's definitely a viable like direction, and people have we've thought about this a lot. Yeah.
Okay. Thanks.
So the demo part is it's four notebooks strung together, and then
Mhm.
at some point it's you generate this notebook is a generation notebook. Here you can do some filtering and ranking, which is like a really key important part. And then you fine tune and then you eval. And it's everything's Java-fied basically, so it's pretty simple to run.
Amazing. Very
Yeah.
easy.
Yeah. So yeah, basically all you do is just point notebooks at different YAMLs or like say, hey, here's my prompt source. It can be somewhere, in Unity catalog, and then we'll ingest everything and spit everything back out of Unity catalog as well. Yeah.
And in terms of compute, do you manage
Yeah.
this in terms of like compute required for this? I guess it's not something huge and you manage it. It's part of the
Yeah.
process.
Yeah, so if people were to run soft, the Databricks had to help manage the compute side of things, right? So we would
Mm.
help you deploy the models for generating the synthetic output data, and then on top of that, all the fine basically once you hit fine tuning time, it's the exact same as normal, just model fine tuning compute wise. So again, this is Databricks managed, and we can help you work through that totally. Yeah,
Like,
just to give a little more visual demonstration of kind of a high level walkthrough. Basically, what soft is, it stands for synthetic output fine tuning. This is a lot of the work that's been done by the feedback team, which consists of me, Jonathan Chang, Ashutosh Baheti, Jonathan Franklin, and Siege Paul. And then, yeah, so again, I think at the beginning of this talk, basically talked about why is fine tuning been so hard. Um, Internally at Databricks, through a lot of customer interviews, we basically realized, hey, the reason why customers actually can't fine tune models is that 60 to 70% of them just don't even have fine tuning data. It doesn't exist in the wild. This just basically is a hard blocker. It means you can't even experiment with fine tuning at all. And so basically, how does Soft kind of solve this essentially? So Soft is a synthetic data fine tuning pipeline. um, Basically, what this means is that this pipeline helps you both generate data and describes how you use this data. And this enables basically customers to fine tune a model with only prompts, basically. So you don't need this input output pair. You can just say, hey, for this given input, I can basically I can rely on this pipeline to generate the outputs to use for fine tuning and improving our model.
And just from a solutions architect side, I would say that we have a lot of customers who don't know that they want to fine-tune models, but they reach out to us to complain about rising costs because they're, for example, querying some proprietary models. So
Totally.
the reason you would want to look at this, at fine-tuning in particular, is that it can really help you for this. But you need
Exactly.
data, which is why soft is so useful.
Exactly. Yeah. So I'd say one of the core ideas that we have here at Databricks is that through our model serving product, basically, we should be able to reduce the cost of these other proprietary models and to bring that cost for customers, basically. And then so with soft, if we want to also reach a higher quality, or an equal quality to these proprietary models, soft is one mechanism to help us increase that, model fidelity, model quality side of things. And then, as basically, if you're a customer and you are using, these proprietary models, if you use Model Gateway, this allows you to log a lot of your prompts into Databricks, and we can see those prompts over time. With that, then you could basically build your own custom, updated llama model on your own prompts. And over time, we can help you improve this as we get better with soft, as we get better with our reward modeling, as we get better with all these different techniques over time. We can help customers improve their own models, basically.
And
So just from the essay side, yeah. So basically, let's say a customer wants to come reduce costs, or they've gone through AI Gateway, they've logged all these prompts. Um, this kind of is where like, soft comes into handy a lot, basically, right? So yeah, for example, customers use OpenAI a lot. They've logged all their prompts. They say, hey, I have all these use cases I want to figure out my language models to do, and now we want to reduce cost by switching to a fine-tuned model. And then so basically this says, hey, how does soft work? One, we generate a lot of synthetic data, and two, we fine tune on this data. And very explicitly, after we generate all the synthetic data, as mentioned before, we want to use this basically reward model that has the ability to rank and order data. And then from here, you basically want to fine tune on it. In this case, you want to treat as preference data. This is kind of just the RL framing of things. But basically it says, hey, again, I now want to make sure response A, my model outputs response A with higher probability than response B, basically, is what we're doing under the hood, essentially.
okay.
Again, you can use it as SFT data, but the full soft pipeline does use kind of this preference optimization. And then so walking through kind of the research steps of what we did basically internally. One, we attempted basically just greedy SFT. We said, hey, on our given set of prompts, we had our own set of prompts, and we said, hey, let's just greedily sample from our model and say, can we even shift the model around very effectively? So you basically say, hey, put the prompt in Llama, and then whatever Llama says in the most greedy sense, you say, hey, this is my best response. And you do normal instruction fine tuning here.
Okay.
And you kind of move numbers around a little bit. You get a little better or hard. A lot of other metrics kind of stay even. Human eval, which is a coding eval, drops a little bit. MLU is about average. GPQ goes up quite a bit. SGM goes up a bit. But there's some changes here. Nothing too crazy. It's okay, right? It'll move things around a little bit. And then again, to present this better, here's the deltas basically. So again, you can see like, hey, arena heart goes up, human goes down a little bit, GPQ up a bit, MSGM up a little bit, right? And then what happens is, because we have this massive set of prompts that we used, we can actually filter out basically bad responses. It's not always guaranteed every prompt is great, and it's also not guaranteed that every response is great. It's very possible that somehow the response goes off the rails when it's greedy generating. It's possible that just somehow the prompt is poor quality. And typically, when you're doing fine tuning or this post training method, you really want this high quality data. And so what rejection sampling does is using the ranked outputs that I mentioned earlier, where I said, hey, for every prompt we generate a lot, you have this ranking. You can basically have this overall ranking across all prompt response pairs that says, what's the overall quality of this entire sequence, basically. And from here, you can actually filter out basically low prompt response pairs. But basically, you put the prompt to the llama n times, and then basically the best output as ranked by the reward model is the synthetic response, essentially. And then again, you do normal fine tuning here that says, hey, fine tune only the best prompt response pairs. You can also filter out these bad sequences.
So you
And
filter
then,
out whatever, let's say that you generated N
Mhm.
prompts,
Yep.
you rank them, and then there's a threshold, I guess, and then whatever doesn't pass the threshold, you throw it.
So per prompt, you generate from Llama n times. And then basically with the reward model, you can say, hey, for prompt, my first prompt, you have response A did great. B did
Mm,
okay. C did like really, really good, better than A. That means
mm,
basically you'd want for prompt one to possibly fine tune on response C, basically.
yeah.
And then the update of this is then you can also say, hey, for prompt five, none of our responses were good. So there's no
Mm.
reason why I should ever fine tune these responses. So you'd want to throw out prompt five, basically. There's kind of two different ways you can like filter this. One is obviously just on the response side, but then two, it would be on also on the just like general prompt being good or bad side of things.
Okay. So let's say that you have prompt A, you generated a couple of answers, and then you
Mhm.
rank them. and then do you always get the best of the answer for the prompt, or sometimes you keep multiple?
Yeah, there's some science here that we've done a little bit where we can
Mm.
like keep both, let's say, for prompt A, responses like one and two, essentially,
Okay.
right? It's possible we do this. It does help a little bit, but it's again like it's there's just some it just depends on your task a little bit.
And just to clarify, attempt one, attempt two, when you talk about attempts, do you mean that you're evaluating different techniques and you're sharing now like the results of those techniques, or is it like a sequence of steps that happens in soft?
Yeah, so this is actually like three different like attempts basically. So like the first attempt is basically like just
Yeah.
greedy, where you just say like, hey, attempt one is just saying for your given prompt, just output the best response that your model thinks it is, and then fine tune your model on it. And that's just greedy supervised fine tuning. This is like the distillation stuff that OpenAI does. Typically, there might be some other stuff under the hood, but this is just like one attempt. And attempt two is a completely separate experiment where you say this is called rejection sampling, and this is where you do the filtering and you generate a lot more. But again, you still just do fine tuning basically. Yeah.
Sounds good.
Cool. Yeah. And then so yeah, and so basically for here again, like you need this verify, you need this reward model. In math and coding, this can be kind of easy, right? So for math, you can say, hey, oh, my answer is like five. And did the model output five? Okay, cool. If it did, then we can,
Sure.
fine tune that. For code, similar story. You can write unit tests, you can do these kind of things, and you can get some nice verifications, basically. But then some tasks, for question answering pairs, for like RAG, for extraction, it's a little less clear like what's the right answer. Or for general chat, right? That's a much harder question to write like verification for. Overall, they'll kind of output a score from 0 to 1, and then it'll kind of predict, oh, does a human prefer this or not, basically. Typically, they've been used on RLHF. And then in practice, basically, what this means is you can just basically take your Llama, let's say in this case 3.170B, or any Llama model, really, or any just generic language model, and then basically you can fine tune them on this preference data. And so preference data very explicitly is this kind of icon on the right, where you say, this occasionally happens in ChatGPT. What they do basically is say, let's say you send them this prompt, and occasionally they'll like give you two output answers basically. One is like, this new answer, and then the other one is the original answer. Which one is better? And this is like the core idea of preference data. This is kind of how you say, and then basically just click, oh, the new answer is better. Then they'll basically say, hey, oh, we should prefer new answer over original answer. And that's actually the training signal that we use to train these reward models, basically.
So how did we collect this answer A and B, and what is the best answer? Is it based on, like, did we crowdsource it between us? How did we know which one we would prefer?
Yeah, so some of this is a bit of just crowdsourcing work, right? So again,
Hmm.
there's a lot of these companies that scale will help you collect this data. So I
Okay.
think we have some preferred vendors internally at Databricks that we've worked with carefully to collect this data just to make sure, hey, like these data, like they help manage cloud records, they get this data at
Okay.
scale, and then we help work with them to make sure, hey, this data is good or bad, basically.
Okay.
The other side of this is there is some open source data on this. It's
Bravo.
okay quality. It works
Hmm.
okay. And then the last bit is basically we also have other methods of the entire field of research called basically like RL from AI feedback, basically.
Hmm.
And the core root of this method is basically instead of having paying crowd workers to do this, you figure out clever ways to use language models to actually help you label data. So you have your llamas, your ChatGPTs, Anthropic models label your data. Yeah.
Sounds good.
And then yeah, so basically, given this reward model that we've trained internally at Databricks, we can say, hey, we can now rank all these responses and say, hey, we can now fine tune them with these responses. And then so basically, why do we think this reward model thing is actually good at ranking these responses? So this figure here is an experiment that we ran with this reward model. And basically, what we did is this is on Arena Hard. Arena Hard consists of, again, some set of questions, and then the end goal is to say, how good is this model compared to the original GPT-4? Uh, on the y-axis is the Arena Hard score, and on the x-axis is the number of generations. Uniquely, what we do here is for each x-axis label, let's say for 2 generations, we generate twice from the given model, and then have the reward model say which one is better. And the unique pattern here is that over time, as you generate more, the final score on Arena Hard actually increases, right? So as you generate, let's say, 8 responses, you actually get a substantial increase compared to just the one generation case. So basically, having the language model generate a lot more, and then how the model ranking it, you can actually surface the better answers essentially over time. And so, for example, you can basically have, let's say, Llama v3 8B reach to the original Llama 3 70B instruct model on Arena Hard, essentially, just with basically this method called best event.
The more we generate, we actually achieve or find the better answer.
So this is kind of something that's come up in LLMs a little bit. And usually the core crux of this theory is that language models have the ability to generate a lot of data. And if you give them enough time to generate this data, they'll actually generate the correct answer. There's a few papers on this that exist in literature. One of them famously from Google DeepMind, and basically it says like if you just let even like just 2B models, old models from a few years ago, just keep generating. Eventually, in this pass K metric, which is say like if you let the model generate 10 times, it'll increase its score over one generation. And so with this, basically what this says is like, hey, if you generate 8 times and you filter the reward model, you can actually surface the one of the better answers from those 8 generations in this Arena Hard case, or 16 times, same story basically. And so that's kind of the core theory of that says, hey, language models have this ability to generate the correct answer. You just need to surface it now. And so the reward model takes advantage of this idea that we just need to surface it basically.
So then the only thing we're sending the model every time to the model every time is just the prompt or some learning from the previous examples that were generated, or we're just asking generator with no feedback.
Yeah, so in this case, in this plot explicitly, there is no feedback. This is just saying, hey, just naively generate like for the 16 column, like generate 16 times for each prompt.
Okay. Interesting. I'm just expecting the model to get better at understanding what it has to create.
Yeah, so there is some work over time that basically says like if you were to properly train this or add feedback, you could probably increase model fidelity even more. But this one's just a very like simple experiment. This has been decently known in like academic literature for quite a few years. This is just called best of n, and basically just says, hey, like as you just need to surface and filter for the right answer with this reward model.
Interesting. Okay.
Yeah, so basically, best event sampling is quite good. You can get actually quite good scores with this. If you have extra compute you want to burn and you're not super latency sensitive, this makes a lot of sense. But yeah, so anyway, going back to the rejection sampling side of things, where you say, hey, for a prompt we generate a lot, then we filter, and then we can filter your data for the best response, and you can fine tune on these prompt response pairs, basically. And so again, this is the kind of table of scores with this new method. What happens here, we can kind of see, hey, we have some improvements here overall. There's a bit of a mixed bag. We get a little more increase in Arena Hard. Some other scores vary a little bit more, but overall, there's still some improvement, a little bit, basically. Oh, nothing super dramatic here yet. That's fine. And then so the last attempt here that we'll present is soft. So basically what happens again, we follow the same procedure of for a prompt, we put that prompt into llama n times. And then basically, because we have this reward model that can rank data in this scheme of, hey, A is better than B, C is better than A, and then we can basically say, from these n responses, what's the general ranking of all of them? You can then basically say, hey, the best and worst output. So in this case, it'd be, from the example I just gave, it'd be like, okay, B is the worst example, and C is the best example. You can use that as a synthetic preference output pair. And then basically you can perform RLHF with this set of preference data overall. And again, all this,
So
the best and worst.
in this
Sorry?
case, you for each prompt you keep two answers, the best and the worst.
Exactly.
Okay.
Yeah. So this one you need for a prompt, the best and the worst. And then from those best and worst, you can fine tune on that data with just basically RLHF methods.
Mm-hmm.
And then so again, this is this updated table with basically all the scores from soft. And what happens is, again, here we can actually see some nice gains, right? So, and this, again, these experiments are a few months old. We've updated them since. Um, but what happens is on Arena Hard, we get this massive gain. On Human Eval, we actually don't just decrease scores, we actually increase scores. And then across the other board, on the other metrics that kind of measure factuality, normally this kind of pre-trained model, like understanding of knowledge side of things, we still get nice gains or like minimal degradation overall.
The demo, like the notebooks seem, it's just a few notebooks that you can apply,
Yeah.
but this is based on a lot of research evaluating a lot of different techniques and then selecting the best technique, which is quite sophisticated, but then now it seems relatively easy to try and apply it. So it's really cool.
Exactly. Yeah, I think the overall goal here is to make this very easy for customers or essays to use, right? So basically, it just says, hey, all you need to really do is drop in your prompts, and then under the hood, we take care of all this machinery for you. All of this basically just generating a lot, the ranking, they would take the reward model side, and then at the end, you can use, our managed eval product agent eval to actually do the proper evaluation, right? So yeah, yeah. And then again, there's a nice bonus experiment basically. Um, and then so from a few slides ago, we basically mentioned best event sampling, which is this idea of you say, hey, at inference time for a given prompt, you want to generate n times and then filter just for the best response and return the best response with this model. And so what if we try best event again after we softened this model already?
So first
And
we
so,
perform soft. So first we fine tune with soft, and then
yep,
on inference we perform best of n sampling.
exactly, yes.
Okay.
That's his experiment, exactly. That's, yep. And then so basically, uh, from our prior like hypothesis of like why this kind of work. We've already basically kind of trained the model to do this good behavior through soft. So we should think best event shouldn't really help. And basically we actually found that this is actually wrong. And so what we mean explicitly by this is if you were to just run basically best event on Arena hard, on the soft model, basically. Again, so we run best event with 16 samples. On the softened model, we were actually able to get basically this Llama 3.170B model all the way up to basically the Claude 3.5 Sonnet, the GPT-4o size style of models, and increase a little bit on human eval scores. So again, we can still get gains on best event even after soft. So again, in the less latency constrained settings where we can use a little more compute, we can still increase model fidelity even higher with basically best event, even after soft.
And then is this though expensive on the serving side?
Yeah, so this is kind of the point on the latency constraint side of things, right?
Mm,
It's like if you have extra compute or you don't get that many queries a second, this can be quite simple. The
mm,
other side of this is because we are running all these samples independently, right? So we're
mm,
saying, hey, all 16 samples are run independently. You can actually just you can just fire them all off at the inference server, and then you won't lose too much, you won't lose a lot of time on the latency side of things. It'll be a little slower, obviously. I'd say, like, again, this is a rough estimate, and I would not necessarily quote me on this number. But for Llama 70B, I think we saw like a 2x to 3x increase in latency. But again, this takes advantage of like you're doing slow QPS, you are hitting the server like once with 16 queries, and then you hit it again with 16 queries for the next query. So it's, yes, it does increase costs, but it does show like in less latency constrained settings, when you do care about quality on on the latency quality trade-off curve, this is
true.
one lever you could pull theoretically.
Yeah, depending on what you're optimizing for.
Exactly, right. So some cases, obviously, this isn't accessible. Other cases, it might be more accessible. Again, it just really depends.
So is it accessible for kind of batch use cases?
The batch use case usually is you're just hitting this inference server as hard as you want.
Mm,
So again, this depends on like how large of a batch use case you have, right? If your batch use case already spans like, a few days or a few weeks, maybe a little less accessible. But if you are a
mm,
job and you don't mind saying in the off hours spending going from like 2 hours to like 4 hours when it's overnight when all the inference servers are down, this is probably pretty reasonable. Again, it
yeah.
just really depends on like which use case you care about and like what batch job you're doing. It'll just vary from
Okay.
customer to customer. Yeah. But yeah, again, going to just basically just raw numbers, you get more increases with best event. on like soft serve basically. Yeah. And then so overall, just kind of summarizing all of this, like what can you do with soft? You can basically get better fine tuning. You can use all these pieces basically very separately overall. Um, and so using the pieces separately, basically what this means is you can do rejection sampling that say, hey, I want to make better synthetic data for like my use case. Again, this is basically this idea of breaking all of your outputs and doing a lot of this filtration. You can also use it for basically RLHF for better fine tuning. You can use this once you have the synthetic data, you can fine tune your model better. And then also again, what this entire just generic process of soft lets you do is say, hey, I can fine tune with only just prompts. And this unblocks a lot of use cases where, again, the core idea is that, hey, these high quality prompt response pairs don't exist in the wild. Because again, it's from the Databricks side, just a large percentage of our customers just don't have access to like high quality prompt response pairs. They can't work with data vendors to get them, and it's just very, very hard to get them. And then again, there's open questions here basically that say, hey, could we fine tune it better when you actually have outputs? It's kind of a bit of an open question, but again, you can also augment, your fine tuning. If you're fine tuning with outputs, you can also augment this to create new prompts that just don't exist already. And then from there, you need to create, these outputs essentially. Yeah, and so what can you kind of do with soft basically? The core idea is you can build better models, right? So for us, it could be like Llama 3.170B with Databricks
Mhm.
Edition. And then so yeah, again, so basically this is a table of the kind of better Llama models that we have. Very explicitly, what we did here is we trained Llama 3.170B on again just a set of prompts that we had, and we were able to increase the 3.170B model to a higher quality than GPT-4o in their May release, basically with soft. And then again, if you apply, best of n, which is a soft serve edition, you're actually able to get to near the OpenAI O1 quality preview quality on Finance Bench. And for reference, Finance Bench basically is something that's like decently close to customer use cases. Very explicitly, what they do is, given basically parsed SEC like 10Ks and 10Qs, answer questions about that basically. So it'd be like, hey, uh, given given this 10K, 10Q, etc. Sorry, again, this is a very contrived example. I'm not a financial expert, so excuse me if I botch this completely. But given like these documents, can you predict? Give me the analysis of like, hey, what are some pain points on free cash flow? What's the given margin what's the updated margin, or what would you pick the margin to be? Basically, stuff like that, essentially. Again, very contrived example. I could be completely misquoting that, but hopefully that's like enough example that it shows kind of the eval benchmark we have here.
Amazing.
Yeah, basically, again, to summarize, with soft, basically, we're building better models here. So for Llama 3.170B, we can improve it. And lastly, and if you're an external customer who'd be interested in, improving Llama models to reduce cost and latency compared to open providers, reach out to your SA.
Amazing. And can this process work for any domain and industry, or are there any preferences?
Generally, what we've seen so far is, I'll go back to kind of these tables, right? So, for example, Finance Bench is kind of this RAG as use case, basically, where it says, hey, I want to do question answering over financial documents. We've seen gains here already, right? And going back a little bit more, just for example, like Arena Hard is basically this very chatty format question that says, hey, on these really hard questions from LLMs, can we improve model quality? And so for that, like we've seen some nice gains from soft as well. And then human eval is basically a coding question domain. So again, we've seen some gains there. So overall, it seems so far that soft has been like pretty generic. There's been no like explicit constraints yet that we found. But again, it might vary a little bit, and you might not see as many gains. But we'd love to hear any feedback you guys have on different domains, different types of tasks you guys are doing. That'd be great to hear.
Awesome. So just to recap everything we discussed, so basically here the opportunity is to fine-tune an LLM like Llama so that it can be cheaper than using, for example, some of the proprietary LLMs. And here, what the research team did, what you guys did, was to benchmark a bunch of techniques and then select the one that worked best. And based on that, build a prototype that means that you can use soft in order to create outputs when you don't have them in order to fine-tune your model. And so yeah, to get started, you can just reach out to solutions architect if you're an external customer. And I guess the nice side is that then you get to also work hand in hand with our Mosaic AI research team, which is really cool.
Yeah. So Brandon, I have a last question. What is the best part of your job?
Yeah, I think the best part of the job is to be able to be like still do very creative research ideas, but then apply them to real world use cases, right? We have these nice like research academic benchmarks that exist, but as we grow as a research team, I think being able to like work with customers closely to help improve their use cases for generative AI. So if that's the route use case, if it's more of these chatbots, if it's more coding stuff, if it's more as you get more into agentic stuff, we'd love to work with you guys more closely on kind of working on understanding your data better. How do you make this data in AI and make you actually make LLMs actually useful for you your use case basically.
Amazing. Thanks.
Thank you.